Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Okay, it's my pleasure this afternoon to introduce David Harper, who is a professor at the Robert Gordon University in Aberdeen, Scotland. I looked at David's webpage this morning, and it said he was interested in two things, people and probabilities, and I think, or something like that. And I think that very well characterizes the work he's done over the years in information retrieval. He's one of the few people who can work and develop interesting new solid algorithms as well as interfaces that allow people to take advantage of those. And I think that's one of the characteristics of his work through the years. He's done a lot of work, some with Dave Hendry here, on interesting novel interfaces that go well beyond the kinds of standard search results lists that we see today. He's done something called profile skimming a couple of years ago to help highlight where the matches occur in large structured documents. And today he's going to talk about some work that tries to take advantage of allowing people to create lists and piles of things that are of interest to them and then exploiting that to find new additional related information. So I'll let Dave tell us about that work. But again, I think one of the interesting things about this is that it's at the intersection of new algorithms as well as interfaces to support users in doing things that are much more simple than, much harder than the one-word and two-word queries that you see on the web.
Thanks very much, Sue. Thank you very much for the very, very nice introduction. I think that does summarize where I think I work, which is somewhere between the interface of interfaces and algorithms and language modeling. I'm going to talk to you today about an interface that I developed to support multifaceted information seeking and targeted relevance feedback. And hopefully through the talk, I'll unpack some of that title for you. As Sue said, my name is David Harper. I'm from the School of Computing at the Robert Gordon University. For those of you who don't know, it's in Aberdeen in Scotland, that small country to the north of England. Or is England the small country to the south of Scotland? I think that's probably truer. And the Robert Gordon University is one of two universities in Aberdeen. This work was done in collaboration with Diane Kelly for the University of North Carolina. I guess I provided a lot of the system skills and she provided a lot of the user studies skills. A very nice collaboration. And I have to acknowledge the work of students and other staff at the Robert Gordon University. Incidentally, if anybody has any queries, any questions, I'm quite happy to take those on the fly. If I think that the question is going to be addressed later on in the talk, I'll say so. If I think it deserves a longer answer, I might very well leave that until the end. Okay, so the outline of the talk, I'm going to talk to you about what I mean by multifaceted or aspectual search. I'm then going to give you a demo of the XRF system, hopefully without the blue screen of death. I'm then going to talk a little bit about the background to this research and why I thought this research was worth doing and some of the influences that I brought to bear in developing the user interface. And then I'm going to talk mostly about the user study that we did, including the aims of this user study, the design of the experiment, and then take you through some of the experimental results and finally conclusions. So multifaceted search, I'm assuming that we've got some topic-based search happening, some overarching topic that we're interested in, and more particularly we're then interested in deepening or exploring various aspects of that topic. So for example, you might have a topic like disaster management, and aspects of that might be command and control, evacuation, supply chain management, communications, medical provision, and so on. So we have this overreaching task, basically what do you do about disaster management, and then as you find information about that, there's various aspects to it, and I'm assuming that the user will be wanting to deepen those aspects, and as they identify new aspects, introduce those into the search mix. So the challenges of multifaceted or aspectual search are essentially managing the complex search situation that results from that, issuing multiple subqueries, and more particularly managing the results that you get back. So there's a certain amount of sort of search management support here that's required, as well as the issuing of queries. What did I say I was going to do next? A demo, I think. Yeah, so the demo I'm going to give you is of a system that we've dubbed XRF. You can think about it as extreme relevance feedback or exploratory searching using relevance feedback. I'm going to take as my topic tropical storms causing loss of life and damage. This is one of the topics from the Trek 8 interactive track, and the aspects here are the individual named storms. So we're assuming the user is interested in tropical storms causing loss of life and damage, and they are then interested in finding as many of those storms as possible, and then for each of those storms trying to find as much information about that particular storm. So you have a kind of two things you're trying to do here. You're trying to widen the search in terms of the number of storms that you locate and deepen the search in respect of the individual storms. I don't know how you swap this, so I'll just end this for the moment. Yeah, thanks. So I've already set up the system here, the XRF system, and I've already started populating it with some results. So what I've done is I've issued a query here, and in some sense the interface is quite conventional. You have a query, you have a ranked list of results, and when you click on one of these results you get the document displayed here. So far so standard, I think. Yeah, so basically query input, ranked list, and document display. In many ways this is quite a simple interface because you'll notice, for example, there's no highlighting here, which one would certainly add, and in fact I have just added. What makes this different from the usual interface is we have a whole bunch of piles at the top here, and what you can do is you can label these piles, and you'll see I've got 3 labels already, one for Emily, Andrew, and Hugo. These piles are color-coded with preset colors as it happens, and what you can do is any result you can assign it to a pile by clicking on the buttons underneath here. So this document's about Hurricane Andrew, and you can see from this shading here that the document is already part of that pile. If I take it out of the pile, you'll notice that this little blue tab here obviously changed color. So it's fairly easy to see whether a document is part of a pile or not. There is no, it doesn't mean anything. These are just piles that are already provided for the user to use and label as they see fit. Exactly. I think what distinguishes this from a lot of work that's been done on the use of piles or clusters, if you will, is that there is no automation going on here. It's up to the user to allocate the documents to the pile, and we did that quite intentionally so that as the search unfolded, the user could determine what the aspects were that they were interested in and then explore those aspects more fully. Yeah, so we have been thinking about that, and I think that will be certainly an interesting thing to explore. Maybe have these piles with 2 parts to them, one indicating whether the document's part of the pile, the other one indicating the extent to which the system thinks that this document should be part of that pile. Yeah, you can assign things to as many piles as you like. I'll just remove them in case you want to use those again. Yeah, so you can assign a document to as many piles as you like. The thing that sort of distinguishes this interface also is that once I have a pile of documents, I can then press this similar button. This is a little bit slow, so it's based on the Lemur toolkit and just uses commands. And what that does then is it issues a relevance feedback search and looks for documents that are like the ones that are already in the pile. And so, fairly obviously, the document that was in that pile is ranked first, and we have other documents here. This one's about Mexico and Hurricane Hugo, as it happens, and lots of these are. As it happens, there are no other documents actually specifically about Hurricane Emily. I think that's basically what I wanted to show you about the interface. Yeah. Any questions so far? Yeah. They're similar to all of them, so it's a fairly classic relevance feedback model. In fact, I just used the canned relevance feedback provided by the Lemur toolkit. So these documents in the pile are considered to be relevant to some query. It doesn't really matter which one, but then the relevance feedback is based entirely on those documents. Yeah. So you can see here that these piles here are then used to basically track the various aspects of the search. In this case, we have piles corresponding to the named storms, and if I want to deepen on any one of those aspects, I hit that similar button. Sure.
Similarity, is that being run on the set of search or on
Good question. Currently it's been done on the whole corpus. It could be either, but no, the idea here was to deepen the search to find documents that haven't been retrieved, or hopefully haven't been retrieved as yet. Another interesting thing about this interface is as I click down through here and I go on to the next screen, and so you'll see here I'm on document 12 of 405. Suppose I wanted to go and review what I'd put in the Hurricane Hugo pile. I can go and click on that pile and see what I've already put in there. What's nice is that I can then go back to my search again, and I'm back in the context of the search. I haven't lost my position. And this is one of the things that the users really liked about this system, that they felt very confident about being able to leave their main search, follow up some sidetrack, and then come back and continue browsing down through these. Okay. If I hit Emily, right? So if I hit the pile itself, it shows me what I've put in inside it. If I hit the similarity button, it then does the similarity search.
when you do the similarity search, the basis so if you did the similarity,
No, actually, fortunately, it's a little, I don't know whether it's smarter or just, no, it actually maintains the context now. So let me do that. This is new functionality, by the way. Some of this is new functionality since I did the test with the users. So if I hit the similar button again, you notice how quick it did that search. Well, it didn't bother to do a search again. So if state doesn't change, it doesn't redo the search. Let's page down through this and get down to document 14 of 1,000. Now I can go back to my search pile, and I'm at 12 of 405. I come back. I don't know what's going to happen here. That's nice. So it does. I knew I'd thought about this. So isn't that funny? Sometimes you develop software and you're not quite sure what it's going to do. Well, that was nice and predictable. I like that. So I got back exactly to the context again. So obviously, it costs a little bit in storage, but I think it was worth it to be able to swap between those searches. The which? This one here? Yeah. Yeah. So it's very nicely maintains the state. There are still some issues about this that I haven't got time to explore because that's not the point of the talk. But yeah, I think we've got a reasonably good setup at the moment. So let me go back to the talk. So that was a demonstration of the XRF, exploratory searching using relevance feedback system. I think that's what I'm going to call it from now on. So the background of this search is the following, that we decided to use this pile metaphor. Now this is not new, it's been used by other people in information retrieval search. Generally it's been used though to actually represent clusters of documents that have been where the search results have been automatically clustered. I'm not aware of, at least any published work, where the user actually allocates the documents to the piles and uses them for relevance feedback. The reason we use the pile metaphor is that it's an informal organization compared with, for example, folders or bookmarks. So it's very fluid. It allows people to very quickly slot documents into these piles. And interestingly enough, while people were doing the searches, if they found a document that serendipitously they were interested in, they could just slot it into a pile. So it's very useful in that respect for just storing away documents that you find on the way. The piles are also used for managing the retrieved documents and for structuring the search process. And I say that because that was the feedback that we got from the users. Even when they didn't have relevance feedback searching available, because we disabled the similar button for at least some of the testing, they still liked the piles because it said it enabled them to organize, to structure the search. And they liked that part of it very much. Yeah. Currently, no, but that would be the intention. That the piles would persist and that there would be a named session so that you could bring the whole session back again. So if you had 4 or 5 ongoing information needs, you would have 4 or 5 sessions that were ongoing. Yeah. You probably would want to do that. You probably want to think really hard about how to do that, but yeah. So that's one part of the background. The other part of the background is the so-called ostensive model of retrieval, which is essentially defined more like this style of retrieval. Namely, users find it easier to point to what they like and to say what they like and to say, I want more things like that, than they do to specify what it is they like about those documents or to generate queries, if you will. This idea about ostensive retrieval obviously has been around for a while. I guess the original relevance feedback work was based on the ostensive model. Ian Campbell in the University of Glasgow used it for image search very successfully, where it is quite difficult to describe images using words, but it's very easy to click on the images that you like and to then follow those paths through the search space. We also explored this idea in some work I did with Georgi Murison, who's currently at Rutgers, on mediated search, where we clustered a small set of documents and then allowed the user to explore that clustered set, find a relevant cluster, and then launch a query out onto a web search engine based on that cluster of relevant documents. So this idea of ostensive retrieval is also behind this. The other part of the background is relevance feedback itself. I probably don't need to tell this audience what it is, but essentially user identifies documents relevant for a topic, and the relevance judgments are fed back into the retrieval process. Now this is an extremely effective technique, but users are unwilling to take explicit actions to mark relevant documents. So in the lab, they're quite willing to mark documents as relevant because that's what they've been told to do. If you release this out into the wild, people do not bother to, or at least in general, don't feel that the payback's sufficiently large to explicitly mark this document as relevant. So a lot of work now has been done on implicit relevance assessments by observing user behavior, by looking at their reading time, looking at what documents they save, what documents they bookmark, and use that as a sort of surrogate judgment of relevance. And the work I've done with XRF, with the pile-based metaphor, is partway between these two things. So what we've done is we use the implicit information in the piles to do relevance feedback, but the piles themselves are a useful service. So the users don't see that as being additional work. They see that as a useful service that they can use, and we then leverage that to get the relevance feedback information. And I think this is a really, probably to my way of thinking, one of the interesting parts of the work, which is how do you get the benefit of implicit, and one way we found to do it is to give them a useful service where you're capturing that relevance feedback information. Yeah. That's just to remind you about the interface again. The one thing is in the experiments, we've got this similar button here. In the experiments, we had one interface with the similar button enabled and another interface without it enabled. So they are the two interfaces that we essentially used in the user study. So the aims of the user study were as follows. Does this interface assist users in a spectral retrieval tasks? Does it improve the effectiveness of the searching that they do? And does it assist the users in managing the search process? So they're the three questions that we really wanted to address in the study. There were a number of possible systems that we could have explored where we had piles or didn't have piles, and where we had similarity searching or we didn't have similarity searching. Mm-hmm. Well, so the spectral search is the search where you have an overreaching topic and then you have subtopics within that, and you want to try and deepen your understanding of the subtopics. I think that maybe you missed that. That was part of it. Anyway, so essentially the tropical storm example, so you have the overreaching topic of tropical storms that cause loss of life and damage, and then the aspects of that would be the individual named storms. That's not the kind of searching that, although, I mean, you can obviously use this. You obviously could use this interface for that. Interestingly enough, even the SIG-IR 2006 example itself has aspects, tutorials, demonstrations, papers. So I mean, essentially it's a way of looking at a search. So I don't think there's many searches many searches have an overreaching topic, and possibly the user has in mind one aspect of that search. But I think actually many searches fall naturally into the multi-aspect category. So as I said, the possible systems for study were four really: with and without piles, with and without similarity searching. We decided to explore this particular pair. So both the systems had piles, and you could either do similarity searching or you couldn't. In retrospect, there were probably, I don't know whether we could have made a better choice here, possibly both with similarity searching, one with piles and one without piles would be an interesting one to do. The next study that we have planned is to do all four, to have all four of these possible systems, and to do that in within subjects, between subjects design, so that we don't have to teach the users all four systems. We just teach them one, but we have a rather large sample of users. But that's not the study I'm talking about today. So essentially this study was an exploratory evaluation of piles. Because there were piles on both interfaces, we couldn't do any comparative study here, but we could at least get some information from the users about how they use the piles, what their reactions were to the use of the piles, and etc. So we saw this definitely as an exploratory evaluation of the piles, but explanatory in comparing piles with similarity against piles with no similarity. So we refer to this one as the XRF system, this one as the baseline system. Of course, we didn't call them that when they were called System A and System B for the users. And our hypotheses were that the subjects will rate the XRF system more usable than the baseline system because of the similarity searching. So we gathered information about that particular hypothesis, mostly through questionnaires. And the second hypothesis was that the subjects or participants will perform better in terms of retrieval effectiveness with XRF compared with the baseline. Did you? So, overview of the experiment. We had 24 subjects, typically library science graduates from the University of North Carolina. We basically had a collection and task, which I'll talk about in a minute, which was the TREC 8 collection and tasks associated with that. And the instruments we used to collect the data were questionnaires, 7-point scales where high is good, as well as capturing what the users did through logging, in addition to basically capturing all of the documents that they saved. Yep.
So would you also give us the baseline system
Yeah, exactly. That was it. It's a very small change. I think, one might argue, well, they're obviously going to notice the difference between the two systems because they have that function missing. Yes, obviously they did. We tried as far as possible to be fairly neutral in the way that we describe both the systems and also in the way we ask the questions in the questionnaire. So actually, a lot of the questions were after they'd used a particular system, so they didn't even know about the existence of the other system when they were at least answering the first bunch of questions. Of course, they knew about both of the systems when they... This is a very difficult area, this whole area of user studies and the order in which to do things. And I don't think any of us has really... Well, I would say that... yeah, I think that's true. For this... within subjects type design, it's very, very difficult to avoid some of these problems. Okay, here's the collection of tasks. So it was the TREC 8 interactive track, a collection of 210,000 financial news articles, rather long in the tooth now, and these are spectral retrieval tasks. So I've got an example here, tropical storms. The four that we chose were tropical storms where the individual storms were the aspect, declining birth rates where the countries were the aspects, robotic technology where developments were the aspects, and increases in tourism where again the countries were the aspects. So the job here is for each topic identify as many different aspects as you can by saving at least one document covering each aspect. This was the way the task was put together for TREC 8. We modified this task slightly. We left the topics obviously the same, but what we asked the users to do was to collect comprehensive information on the different tropical storms and as much information about each storm. So we were actually trying to get them to use the interface in terms of broadening the number of storms that they found and deepening the information, finding more information out about each storm. What's important here is that the relevance assessments that were done for TREC 8 would work for our experiment as well. The only problem that we did run into is we think we hit some recall ceilings. Namely, we think that our users started to probe parts of the document space that hadn't been hit by the TREC 8 experiment. Which was sort of regrettable, but difficult to avoid, really. Just to say a little bit more about that, in most of the TREC tracks, there's a lot of groups participating, and they're retrieving a lot of documents, and all of those documents are assessed. So you have lots of queries, lots of groups, and 1,000 documents are returned by each group, and they're all assessed. In the interactive track, they weren't able to assess as many documents because of the spectral nature made the assessment task much harder. So they're only able to assess about 100 documents per group. And so arguably these are not very comprehensive relevance assessments. Okay. Yeah, the TREC judges went through and they said this document is relevant and it covers the following aspect or aspects. And robotic technology. Countries and tropical storms, not so difficult. Very, very difficult for the robotics development. The protocol for the experiment is we issued a demographic questionnaire. We then demoed the first system. They did a practice search task, 2 searches, and then answered a usability questionnaire, or really a post-system questionnaire about their experience with that system. And then we repeated that for the second system and an exit questionnaire. So that's the general protocol. The design of the experiment was Latin squared. So the participants were divided into 3 groups. Each group essentially comprised 8 participants, where the tasks were rotated, and the systems were used in either first or second. So this was a full rotation, a full Latin squared design. And this particular design, as you probably know, counterbalances the effects of learning and ordering. It's fairly classic design now. So that would be one group of participants. The second group would be in exactly the same form, and the third group. The benefit here, of course, is that any measures that we take over these systems that we then average, we can then be fairly sure that they won't have any learning or ordering effects, so that we can confidently take averages of various measures and compare our XRF system against the baseline system. The measures that we used were many and varied. So let me try and unpack this for you. Across the way we have the aspects of the search, down the way we have whether a document is relevant, whether a document is non-relevant, and whether it's it hasn't basically been assessed. And so what the blue blobs here represent is that the first retrieved document here is basically relevant in respect of aspect 1 and 3. Here it's 1 and 2. Here it's 4, 4, and so on. So aspectual recall is the proportion of aspects that are retrieved or covered by the retrieved documents. So here I'm assuming that I've retrieved these 4 documents, and you'll notice that we cover 3 out of the 4 aspects. Or do we cover them all? 3. Yeah. I think that's right. Oh, yes. So the second aspect is not covered by any of the documents, so the aspectual recall here is the proportion of aspects covered by the retrieved set. Recall is the standard measure, which is the proportion of relevant documents that are actually retrieved. So of the 6 relevant documents, only 2 have been retrieved, so that's 2 out of 6 for recall. Aspectual precision is the proportion of retrieved documents that are indeed relevant. So we had 4 documents retrieved, of which 2 were relevant. So the precision is 2 out of 4 for that. I've got to say that they referred to aspectual precision in Trek 8, but it is exactly the same as precision. So there is no difference between precision and aspectual precision, as far as I could see. Going beyond that, Precision D was using all of the documents. So basically, we've got relevant documents, non-relevant documents, and documents for which we have no assessments. So Precision D is the classic using all the documents. Precision K is precision computed where we only compute it using the documents for which we have known relevance assessments. And we thought that that was probably a fairer measure to use for a system that wasn't being compared in the original experiment. The Precision K was a fairer measure for our system. Is everyone with the measures? Anybody need to, anything there that I need to go over again? Okay. How long have I been going? Seems good. Oh. Okay, so I'm going to launch straight into the to having a look at the results of the experiment, and the first thing I'm going to do is to go through some of the results from the questionnaires. These were basically the questionnaires that were that the users filled in at the end of using both of the systems. That they filled in after they'd used a particular system. Remember, this is a 7-point scale where 1 is bad and 7 is good. So high numbers are good here. We didn't expect to see any difference in ease of learning or particularly in ease of use. And indeed, we didn't see any effect here. The numbers are all quite high. So anything above 5 is good. 6 is obvious. 6 and 7 is obvious. Well, 7 is obviously best. So anything in the 6s is a good result. There's not much to say about this, to be perfect, to this particular set of results. In terms of usefulness, I'm not sure about the labels of these slides. So we asked some questions like, did it give you control over your searching activities? Did it make things that you wanted to accomplish easy to do? And did it save you time? And this is their perception as to whether the system they were using saved them time, made things easier for them to use or not. And these two questions were actually statistically significant. In other words, the difference between the baseline and the XRF system was statistically significant, and they felt that the XRF system made things they wanted to accomplish easier, and they thought it saved them time. Now, interestingly enough, they had 15 minutes to do the particular task that they were set, and yet they felt that the system was saving them time, this similarity-based search system, compared with the system without. In terms of their effectiveness, how effective they thought they'd been with the system, or how effective the system was from their point of view, there were 3 questions here that elicited statistically significant differences. Functions well integrated. I don't know what to read into that particular. Able to employ all the search strategies that they wanted. There was quite a large difference here between the baseline system and the XRF system, but notice the numbers are quite low. So these were library students who were used to exercising all of the search strategies that were available to them, and of course some of those were not available to them using the XRF system. And in particular, they really moaned about the fact that there wasn't a function 6 button. Now, it turns out that if you use something like dialog and you hit function 6, I think it is, it does highlighting of query terms for you. So they really would have liked to have seen at least highlighting available. Some of them actually also said, I'd really like to be able to use not. Now, I'd like to be able to use Boolean operators. I'd like to be able to do Boolean queries. Fine. Okay, that's fine. Apparently users still like to do that, especially library students. Only library. Well, yeah, exactly. Only. I don't know anybody else apart from library students. I guess
Did they
if...
ask specifically for Booleans, or did they ask to be able to exclude things?
Yeah, I'm being a little unfair there. Some of them did actually ask for Booleans, but what they really wanted to be able to do was to exclude bunches of material. As it happened, I think that they were... Their motivation for it was probably wrong, though. So, for example, this query about tropical storms, there was a lot of material about Lloyd's Insurance in London, because this was Financial Times. But it turned out if you went down and dug in those documents, often they were talking about tropical storms and the effect on the reinsurance market, for example, and talking about loss of life and damage and how costly it had been. So they wanted to exclude all the stuff about insurance, but actually they would have knocked out heaps and heaps of documents that were relevant. So, which, as you all know, is probably one of the biggest pitfalls of using the not operator. So I am not considered harmful in the way that goto was considered, or still is, harmful. And it was reckoned to be more effective in helping them complete their tasks. So presumably the provision of the relevance feedback, similarity searching, in their view, helped them complete their tasks. And some of them said, for example, in more informal comments that they provided after, that the relevance feedback searching gave them a feeling that they'd gone as deeply as they could for that particular aspect. Yeah.
So all these questions were asked after it dealt with each individual tool.
Yes.
So, one thing that might be interesting to do is split apart the result one system first versus the other.
Yes.
Look at them in their own terms. In particular,
Mm-hmm. Yeah, look, I'd hate to swear to this, but I'm fairly sure that we did an analysis of that kind, and it didn't seem to change the results very much. Only 24 users. Yeah, it's 12. It's going to be, yeah, you're right on the edge of finding anything out there that's going to be significant anyway, but yeah, but that's always a problem with it.
But I think the main thing that would be really interested in is comparison of those two use it as sort of second.
Yes.
Because they would have had some contrast.
Mm-hmm. We also asked a whole bunch of open-ended questions, particularly in the exit questionnaire, and some of the things that the users said was that they liked the similarity feature. It gave them more control, helped them find more relevant documents, gave them a sense of task completion, and so on. And these are not, although I've quoted individual comments here, these were comments that were made over and over again by a lot of the users. They specifically commented on the ability for the piles to help them organize their searching and search results. Yes?
So they were being asked like many
Mm-hmm.
Similarity would actually do that for finding the best.
Right. Yes, exactly. But they were being asked to do two things at the same time. It's a pretty difficult ask for the participants. They were told to kind of balance. You've got to try and find as many different storms, and you've got to try and find as much information. So there was a genuine tension for them about whether to go wide or deep. And so they sort of did some of both, actually. So they widened, and then they deepened, and then they widened some more and deepened some more. This is very typical of what was said about the piles. The piles allow me to keep my searches organized. And here's the kicker, so I can confidently follow tangents that might lead me elsewhere. And they really like that, to be able to follow this tangent and then to come back to their main search again, or what they considered to be their main search. When they were asked at the end in the exit questionnaire what their preference was, they expressed the preference of 22, a preference for XRF, one for the baseline system, and one for Google. Well, go figure. That wasn't one of the choices. The question was, did you prefer X or Y? And they said Google. So I guess we had a stand-up comedian in our midst. I don't know what to read into this particularly. I mean, if I give you a Ford, or I give you a Ford with alloy wheels, or whatever, air conditioning, I guess you go for the Ford with air conditioning, I guess. So I'm not reading particularly much into this particular finding here. The negative comments they made were mostly about low-level interface issues. So mostly about things like, I'd really like to be able to have longer pile labels. I'd like, perhaps not low-level, I'd like to have more piles, because some of them started to hit the limits of the number of piles. Some of these searches had 24 and 36 aspects. So the 12 piles that they were able to use in the prototype clearly weren't enough for those sorts of searches. And they commented particularly on the non-availability of highlighting. So I guess the results provide some support for our usability hypothesis that the subjects will rate XRF more usable than the baseline. This is just I was going to say, I've given this talk a couple of times, and I said this is for the geeks in the audience. I'm not sure whether that's appropriate here. Well, maybe some of you aren't. But anyway, it's written in Java, and it interfaced with the Lemur toolkit just via system commands and files. So it didn't use an API, it just basically used systems commands. Actually, the performance is pretty good considering that fact. We gathered extensive logging data throughout the experiments, and that logging data was saved in XML marked up files. So we developed an XML language to describe the log files, and that was then processed by a Java DOM program and output to Excel spreadsheet. So that was I'd never used XML before, so this was the first time, and it was actually a pretty cool way of capturing the logging data. You probably do it habitually, but I do strongly recommend it now to students in the audience as the way to go here. So it was definitely a very flexible approach. I'd like to talk now about the measures that we captured about interaction. So this was basically capturing from the logging information, having a look at things like how many queries they issued per search, how many similarity searches they did per task, the number of documents they saved, and so on. So the first one I'd like to look at is they issued significantly more queries for the baseline system than for the XRF system. This is perhaps not surprising. They didn't have a similarity search available, so the only way they could do new searches was through issuing a query. Obviously, there were no similarity searches available here, but on the XRF system, on average, they did about 4.61 similarity searches. So, just... Yeah, exactly. So I would conclude from this that effectively they did about 7.5 queries here versus 5 here. So there was more, in a sense, there was more search activity enabled by and possible using the XRF system. These are mean values, yeah, with standard deviations in brackets. So standard deviations are fairly huge here, you'll notice. In terms of the amount of interaction going on, all of the measures for XRF were slightly lower than for the baseline system. So they saved fewer documents, they displayed fewer documents, the pages of snippets they displayed. So all of the numbers were smaller, none significantly so, but all smaller on XRF, which suggests to me that they were probably doing a little more thinking here and a little more read time here compared with here. I don't know what else to read into that, apart from, they were doing fewer searches here, so they were obviously spending more time paging through results and having a look at individual documents. They had 15 minutes, so they were displaying. Sorry. Yeah, they had 15 minutes. So on average, they were saving about 1 to 2 documents per minute of time that they had available. I seem to remember different numbers from these, but I thought that they were processing about 3 or 4 documents a minute, and I think that's true. So they displayed about 40 to 50 documents per task. So they were displaying about 3 documents per minute. So they were working quite fast, and quite fast considering these documents are not all short. They can be up to a page, and they didn't have the benefit of highlighting available to them. So they're doing about a document every 20 seconds or so. So I actually think they did pretty well when we'll see the results in a minute. This was interesting to me, the number of piles they used. Even though on the baseline system, the only thing the piles gave them was the ability to save documents in piles. There was no similarity search. We didn't even say you have to use the piles. We didn't give them any instructions like that, just use the systems as you see fit. They basically used about the same number of piles for both the baseline and the XRF system, which suggests to me that they were finding the piles useful even without the similarity searching. On the XRF system, they used on average 3.5 of the 8.5 piles that they generated. So that they basically generated about 7 or 8 piles they used, and they used about half of those for similarity searching. I think that number may very well be a function simply of the fact that they were only given 20 minutes for the task. So did the users use the piles for similarity searching? Yes, they did. The mean number was 4.61, ranging from 0 through to 15. So 5 of the users, when they were using the XRF system, did not use any similarity searching at all for 5 of the tasks. They actually commented on this. They said We would have found that it useful to use similarity searching, except that we were finding so much relevant material using conventional searches that we didn't need to go to the similarity search. And this was particularly for the robotic technology task. Once they'd done a reasonably good query, they just plowed their way through the results, collecting relevant documents. And the mean number of piles they used were 3.5, but ranging from 0 right up to 11. So one user actually used every pile that they generated for similarity searching. How large were the piles, you might ask, when they actually issued the similarity search? Well, I think this is interesting. I don't know the number, but 54% of them did a similarity search when their pile had one document in it. Now, those of you familiar with relevance feedback searching will know that it's usually best if you have 2, 3, 5 relevant documents. But they chose to use the piles when they had just one document in it for similarity searching. It also suggests to me that more like this operation that you see in Google would be exploited more if you provided it in a way that people, perhaps in this pile-based way or some other way. But my own feeling is that more like this search in Google doesn't get used that often, but I don't have any data on that. I don't know whether anybody else has or not. And you can see that something like 80% of the searches only involve piles of size 3 or less. What this says to me as an information retrieval person interested in algorithms is if you're going to develop systems like this one, you better make sure that they're optimized for very small numbers of relevant documents, and you might even need to choose the number of terms to feed back into the process depending on how many relevant documents you had. A lot of these relevance feedback systems just have a preset number of terms that you feed back. You might really want to think about that in more depth. So I think there might be a really nice little research project around about this particular area. Okay, here's the money slide. Unfortunately, it's not. When we looked at the effectiveness measures between our baseline and XRF system, probably most of you will not be that surprised. The numbers were almost identical, which was a source of some dismay to us, the experimenters. In other words, they did equally well using the baseline system as they did using the XRF system. As it happens, these numbers are quite good. These precisions are quite high. This aspectual recall is quite a high figure as well. I really don't need to go. I mean, you see the message loud and clear. Essentially, they did the same with both of these systems. I should be a bit more careful in what I say there. The effectiveness measures were the same for both the systems. What they actually did with the two systems was quite different, and we haven't had time to analyze that yet, but they were definitely finding different sets of documents. I developed a kind of nice analogy for this. Let me see if I can recall it. Imagine you've got a monkey who is trying to collect fruit from trees. And his or her job is to collect as many different colored fruits as they possibly can. So one strategy might be to run to the bottom of one tree, leap up that tree, gathering as much fruit as they can, and when they think they've got enough of that color, go down, run to the next tree and climb that one. Another monkey says, look, I'm up this tree and I can see the fruit in the nearby tree. It's just there. I could just leap to the next branch of the next tree, strip that one, and then follow the other branch. So one monkey goes from crosses the branches between the trees, and the other one climbs the trees individually. The tree climber is effectively the person who issues queries, and the person who's jumping between the branches, that's much more like this relevance feedback approach. You find a relevant document and you follow that path basically. So, I do think that the actual documents that they retrieved, the trees that they were able to explore with the two systems were different, but I haven't got any numbers on that yet. Right. I think you're right. So we're unable to reject the null hypothesis. As far as we're concerned, they performed equally well in terms of retrieval effectiveness. So then we asked ourselves, well, how did we compare against the Track 8 interactive track? You know, if we compare the performance of our set of users against the systems that were evaluated in Track 8, how do we do? Okay, so first of all, some caveats on this comparison here, and there's lots of them. They're strictly not comparable because of differences in the experimental conditions. In particular, the users or subjects are different. So our set of users was different from the set of users used in those other experiments, so they're not strictly comparable. Our users might be super users. They might have used a whole bunch of graduate students that weren't very good. As it happened, the best performing system in Track 8 was the Z Prize system from the University of Berkeley, California, and they used graduate library science students. So in some sense, this comparison is not completely invalid. Track 8, they gave them 20 minutes per task. I don't know why, but we gave them 15, making the job much more difficult for our users. Our spectral retrieval task was different. So it was more elaborated than the original Track 8 one. But I must stress that the relevance assessments are valid in both experiments. And Track 8, all the retrieved documents had relevance assessments. Anyway, I'm going to compare them anyway, right? So, but you do understand that there are caveats. Yeah. No, the source of documents was 210,000 Financial Times documents, basically newspaper articles from 1991 to 1994. I suppose I shouldn't be drinking cans of water. I'm being recorded, aren't I? Oh, well. And now a word from our sponsor, Talking Rain. Actually, that seems an incredibly appropriate drink for Seattle, doesn't it? Okay, so strictly not comparable, but we're going to compare them anyway. So the blue is the Track 8 average. The whatever this color is Z Prize, which is the best performing system in Track 8. Yellow is the baseline, and light blue is the XRF system. So the first thing to note is on their spectral recall, which is the extent to which you cover all of the aspects, our system was better than the best performing Track 8 system. This for me was almost remarkable because I think there was a tendency in our users to deepen their searches, to go for the sort of deepen each aspect rather than broad, and yet in deepening the search they also broadened it at the same time because some documents had more than one aspect. So you'd save a document and you'd get the credit for all of the aspects covered by that document. But I couldn't do the numbers on this because we didn't have the I didn't have the data available, but I suspect that might be a statistically significant difference. In terms of precision D, which is when we do the precision with all of the documents, Z Prize, in fact, on average, the Track 8 systems did better than we did. But if we only use the documents with known relevance assessments, you'll see that our average is then comparable to the Track 8 average. And again, Z Prize has a higher precision. So one thing I would say is XRF in the baseline system, we didn't have any highlighting. And I think this was a significant problem for our users. Our users actually had to read the documents to see whether they were relevant or not, as opposed to being able to see highlighted terms really quickly and make very fast decisions. So I suspect our system would actually perform probably far better with the highlighting in place. As I said before, I think that we were running into a recall ceiling. In Track 8, 278 documents were judged relevant. In our experiments, we found 268 of these. So I think we were definitely getting close to the recall ceiling. I'm sorry? Oh, that means over all of our experiments. our users managed to find 268. I'm not saying any particular individual did. Yeah? Judge non-relevant, we had 59 documents for which we had no assessments at all. So, you know, I have no idea whether any of those are relevant or not, or whether some proportion is relevant, but certainly 59 of the documents that were retrieved by our users had no relevance assessments for them in the original Trek 8 experiment. So we don't know whether they were relevant or not. There were, I think about 10, maybe 12 of that order. So, you know, this is quite extraordinary actually to find, you know, given that our poor old users only had, you know, 15 as opposed to 20 minutes, and they still managed to find 60 documents that hadn't been found by any of those other systems. Mark you, this is only the top one. This was in the top 100. And I can fairly confidently say that none of our users went below 100 documents. Okay, what do we conclude from all of this? Well, sadly, I guess, the quantitative results show that XRF and the baseline system are comparable across a range of effectiveness measures. The comparison with Trek 8 suggests that XRF and the baseline are better on average than the systems tested, at least for our spectral recall. And our spectral recall is better than the best system. Precision K is comparable. So it's probably a bit strong as better on average. Better on average for our spectral recall, I should have said. But note the caveats. The quantitative results definitely show some support for the hypothesis that XRF is more usable from the user's perspective than the baseline system. There was very strong support from the users for both the piles concept and the similarity search. So time after time they said they thought the piles were a tremendous way of managing and organizing search results. And my conjecture would be that improving just some parts of the XRS interface would improve these results fairly significantly. I think they'd be able to look at a lot more documents. Of course, the problem is it also gives them scope for a lot more precision failures then. So the more they see, the higher the recall, but classically, the more mistakes that will be made. As far as future work is concerned, I think there's a lot of interesting work to be done on analyzing the log files and to determine which search tactics and which users did best in terms of success and failure in searching. I think it would be really interesting to have a look at that and to then redesign the interface to encourage the good tactics. So in other words, if we find that some users are consistently doing better than other users, what are they doing that makes them better? Can we introduce something into the interface to encourage people along those paths of righteousness, if you will? We are planning a larger scale user experiment to better isolate the effects of piles and relevance feedback, and we're going to test all possible 4 systems in a between subjects design. The idea here that we'll have more users, but we'll only have to introduce them to one system. And we're obviously going to redesign parts of the XRF interface based on feedback from the users, which has already been done. So I can give you another demo if anybody wants to have a look at it afterwards, which we've got a new highlighting system in place, which works very nicely. And I think that's it. Thank you very much for your attention.